just like all of the other topics, well, most of the other topics, we do have some proofs that we can work on to use what we know about quadrilaterals. So I'm going to do 2 of the proofs for you, and then obviously you can work on the rest of them. So here's number 1. It says, given x, wx, y, z is a parallelogram, prove that wx is congruent to y, z. So things we know here. We do know it's a parallelogram. So remember, when you have a parallelogram, keep in mind some things about parallelograms. Opposite sides are congruent. They have 2 pairs of opposite sides parallel, so we have parallel and congruent. And then we have some diagonals bisecting each other. We have opposite angles congruent, and we have consecutive angles supplementary. So 2 angles in a row would add up to be 360. So those are some things we know. By our definition, we know that it's a quadrilateral with 2 pairs of opposite sides parallel. So those are some things we just automatically know and we can keep in mind to use as needed. Okay, so they have given us that. So we want to prove that WX, so let's go ahead and mark these. I'm going to mark them in light highlighter so we remember what we're trying to prove. W to X, we want to prove W to X is congruent to Y to Z. So we want to prove that these 2 are congruent to each other. So clearly we have to follow their steps. This is a puzzle proof, so they give us our options. Now before we even start, let's keep some things in mind. So remember that we have statements on the left. Now statements look like they're presenting some kind of something about the picture. Now remember, reasons are things that come off of our pink sheet in the back. So if I look at all of this stuff down here, I can just think about the reasons. So anything that would be on a pink sheet, theorems, definitions, anything we know like that. So let's look through this stuff. What kind of things show up on the pink sheet? This one does. Consecutive interior angles does. Angle side does. Definitions do. Corresponding parts of congruent triangles do. Angle side angle does. Does this show up on the pink sheet? No. So that would be a statement. So this is something that could go in this column. Alternate angles, interior angles are congruent. That shows up at the pink sheet. Definition of parallelogram, all the definitions show up in the pink sheet. This right here is specific about this picture. This does not show up on the pink sheet. So that could be a statement. Transitive property is definitely on the pink sheet. So you see how we have 2 blanks here? And we have 2 green ones. So these 2 green ones have to go in these 2 blanks over here. So sometimes that's easy peasy lemon squeezy. And look right here. We want to prove, let's undo that color. We want to prove these 2 yellow pieces. So clearly the prove is going to go right down in this bottom spot right here. So we can have another giveaway here that this one, WX and YZ, that's going to come right down here, because remember this goes right down here. WX is congruent to YZ. So just by default, we do know that this one's going to end up going right here. WY is congruent to WY. Oh, and duh, WY is congruent to WY. That's reflexive property. Remember that that's anybody congruent to themselves. So same Z's. That's going to be reflexive property. So those 2 were easy ones to get. Okay, so let's go through the proof here. So first we were given it's a parallelogram. Given, got it. Okay, the next part they say that WX is parallel to YZ. So that means this piece is parallel to this piece. Also, WZ, that's this side piece, is parallel to this side piece. Now remember, parallel does not necessarily mean congruent. So why do we know that those two are parallel to each other? And it has to be something from above. So it's probably this word right here. It's probably the definition of parallelogram. Because in our definition of parallelogram, didn't it say that? Parallelogram. Quadrilateral with two pairs of parallel sides. So, yep, it says it right there in the definition. So we do know that this is going to be a definition of parallelogram. Oopsie. Definition of parallelogram. So that's done. This one's used. This one's used. Okay. So here's what we got going on so far. Now the next thing says, now these are kind of confusing. Remember, do them in order. Z to W to Y. So let's find that angle in our picture. So Z to W to Y. Z to W. Z to W to Y. Z to W to Y. So we're talking about this little angle up here is congruent to X to W to Y. I'm sorry, X to Y to W. X to Y to W. So that's this guy right here. Okay, so that's my green guys. So look at my picture. Why do we think that these two might be congruent? Now, they're not something like vertical angles, right? And we don't have any congruent triangles, but remember when we have parallel, what are we supposed to look for? When we have parallel, we should look for a Z. So we have a set of parallel lines here. Boom, boom, boom. Do you see the Z? Those are in the cracks of the Z. So those look like alternate interior angles. So these look like alternate. Okay, let's check the other pair. So let's check this guy out. So we have W, I can't even read my letters today. I don't know what's wrong with me. Z, Y, W. So Z to Y to W, so that's this guy right here, is congruent to X to W to Y. X to W to Y. So that's this guy up here. What are these two guys? Do you see the Z the other way? So let's find the Z the other way. So you see the blue Z here? So these two blue double angles are in the cracks of that Z. So that does make this to be alternate interior angles also. So these are both pairs of alternate interior angles. So let's look at our choice. Alternate interior angles right here. So alternate interior angles are congruent. Okay, so now we're going to, these two triangles are congruent. So remember that whenever they're talking about congruent triangles, we have 5 options. So what are our 5 options in our notebook for proving triangles congruent? We have side, side, side. We have angle, side, angle. We have angle, angle, side. We have side, angle, side. And we have hypotenuse, leg, right angle. So these are our 5 options. Remember, this is for proving triangles congruent. So the only thing that could be in this spot over here is one of these 5 options. Do we have any right triangles or right angles? No. Do we have a bunch of sides congruent? It doesn't look like I marked anything congruent in this picture, except for this one. Oh, we probably should have marked that though, right? Because we had this number 4 here. So we did have this piece congruent to itself in the center. So we do have one side, right? So remember what we did now. We looked at this picture and we asked ourselves, so what do we have congruent? And remember how we put A's and S's on everything. So let's go ahead and do that. So let's look at this picture. Now remember, these arrows, we don't get to mark because we did not say they were congruent. That's just parallel. And remember, parallel could be different lengths. But we do have these two green angles. So those are both a pair of A's, right? So we have a pair of black A's. We have these two blue ones. And so we have a pair of blue A's. Well, they're red now because I just drew them in red. And then the only other side we marked congruent was this orange guy in the middle, right? So we do have one side in the center here, right? So we do have two A's and an S, which means it could be this one or this one. Okay, so we have to decide, are they, remember we only look at one triangle now, so let's look at one triangle. I'm going to go ahead and look at this bottom green triangle right here. And I'm going to ask myself, is my S touching both of my A's, or is my S only touching one of my A's? So if I look in this green triangle, you see how the A here and an A here, and you see how the S is right in the middle. So see how this S touches this black A up here, and this S also touches this red A down here. So my side does touch both of my A's. So this is an example of angle, side, angle. Is that an option down here? Looks like it is. Boom. Okay, the last piece was this top yellow and this bottom yellow. So if this green triangle is congruent to this blue triangle, then that means all of their corresponding parts are congruent. So since these two triangles are congruent, and we stated it right here, we can now say that all of their parts are congruent. And if you remember, all of the parts congruent, that's this one right here. So it is corresponding parts of congruent triangles are congruent. So that is CPCTC, corresponding parts of congruent triangles. And remember, you could only use that if you already proved that these two triangles were congruent. Okay? And remember, to prove triangles congruent, you only have these 5 options.